force probe. This is a cart. And this is a spinning turntable. And there's kind of a track here that the cart's allowed to slide back and forth on. And there's a pole in the middle that the whole thing is connected to. So I'm gonna kind of erase this stuff that's distracting, but that's basically what we have set up here in this question. Hopefully you all have taken a chance to look at it. And I know some of you have submitted your homework, and if you decide you want to submit more questions now that you've finished, just send them through EDSB as a message. So it says the dot below represents the cart while undergoing uniform circular motion, and at the location shown in the figure above, on the dot draw and label the forces, not components, exerted on the cart. Each force must be represented by a distance, blah, 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 blah. Their picture is a side profile picture of this, with the turntable being kind of, let me get this a little bit better. Turntable being like that, and the cart being right here, and the pole being there. All right, so that's kind of their picture, and a terrible sketch, but we're in a hurry to try and get this out there. So they want me to take and draw the forces acting on the cart. No problem. We're definitely going to have weight of the cart. We're definitely going to have normal force on the cart, and there's going to be some tension on the cart in that direction. So that should be pretty straightforward. Probably not giving you a whole lot of points for that. Yeah, but I believe the track is just something that allows the car to move freely left and right, depending on how fast it's being spun. That's my inference of it. I don't think the track is doing anything more than that. I think it's to keep it from slipping along the top of the turntable, so that the car can't accidentally go that way or that way, but can only move forwards and backwards. Does that make sense? All right, so they tell us actually a few things in the problem, which is why I want to be clear that they clearly don't care that much about some of the things that you're supposed to know, because they just tell it to you. Like, they say that the object has a tangential speed of v, and it's at a radius of r, and that it's obeying centripetal motion v squared over r. And they give all of that to you in the treatment of the question. So they're basically spelling out not only that that's r, and not only that this object has tangential velocity like that, but that you're supposed to know this, which, just to be honest with you, I hate that they put it in the problem, because although that means the students have access to that knowledge, it also means that the students don't get any credit for knowing that. And to me, understanding that this acceleration is related to the velocity is an important detail. It says, using the experimental apparatus shown above, design an experiment that a student could use to verify the centripetal acceleration of an object undergoing uniform circular motion with a tangential speed of v, a radius of r that can be described by this equation. And in the table below, what would you measure? What would be the symbol for the quantity? And what would be the equipment for measurement? Well, if all we're trying to do is verify this, well, there's a few things we're going to have to know. And the first is that our measuring devices are not going to let us measure the centripetal acceleration directly, but they will let us measure this tension directly. And we're told that there is a force probe there. So I'm pretty sure that this tension is coming from the force probe, which means we have something that will give us a value for force. Well, that suggests then Newton's second law. So using Newton's second law, that tension has got to equal to be mv squared over r. So when I start looking at the equipment I'm going to use the force probe to measure the tension. It doesn't say I have one, but I could just as easily grab that force probe and hang the car from it, which will allow me to measure M. I also might have a scale if I was in my classroom. They tell me that the turntable gives me the ability to measure the velocity and adjust the velocity, and I could use a meter stick to measure R. So quantity to be measured, those are the 4 things that I'm going to have to measure. The symbol for each, pretty clear, and the equipment I'm going to use, pretty clear. Any question about that? All right. So I wouldn't, and here's why I wouldn't. Let me get to the part of the problem that says it. I'm trying to see what they would give me. I guess you're right that it's not actually clear in the problem that from the turntable I am getting a value for the velocity. They're telling me that the car has a velocity, but they're not telling me specifically that I can use the turntable to measure it. So I'm trying to think if we could use, I think it's hard to use a motion detector to measure the velocity of an object that's turning. So I think we're probably not gonna be able to use so let's say that we don't have the velocity. What are some other options for us to be able to tell AP we know how to measure velocity? Yeah, I think that's an option. So for those of you who didn't hear all of that, we could use this relationship that we've talked about before and find a way to measure period. We'd use a stopwatch and measure the velocity by using the diameter and the period. I think also it would not be terribly uncommon for a turntable to have an angular velocity setting. I mean, record players do. Record players have 33 1/3 and 45 and 16 and 72. So they have specific angular velocities. And we could also say that the turntable's settings for angular velocity could be used to compute the tangential velocity. Neither one of those would be considered too far out of the realm of possibility. Now, if I continue to read the problem, they point out the period. So probably they are steering us. Well, that's the second part. Yeah, but it's definitely in line with this. So the fact that they're pointing it out suggests that they would be okay with that. When we're looking at what would AP Central see as reasonable things that you could do in a science lab, if they point out one later on in the problem, there's no reason why you couldn't use it when you were dealing with yours. They would just want to know if you understand how the period relates to the velocity. So, go ahead. Yep. Sure. And in fact, that's exactly what's being suggested by the data that's there. So I'm going to go to a new screen here to talk about how we would deal with the data. They're giving us specifically the force and the period. And they give us 2 columns to deal with how we're going to use that to get things that we can plot. So we already realized that the period is going to be 2 pi r. I'm sorry, I should not have done that. That the velocity is 2 pi r over the period. So that means this column, I'm going to write 2 pi r over the period is what I'm going to plot there. And the acceleration is going to be the force divided by the mass. So I'm going to put that there. And this represents the velocity, this represents the acceleration. Now, right, I'm sorry, the force would be the tension. So it says use the remaining columns of the table as needed to record any quantities that you indicate are not given. Label each column you use and the included units. And what on the grid below, plot the points. And I also want to know what would we... Oh, wait, I'm sorry, you guys. You should probably trust your teacher better than you are right now. It says indicate the two quantities that could be graphed to yield a straight line whose slope is the mass. So all of you who are paying attention to me, I got focused on the prior question about showing the other relationship. But because of that, I'm sorry, I'm gonna retract my words here and say I'm not gonna do that at all. I only need one column, but I'm gonna square it. And I'm gonna have to do more than that. You know, Josh, you should trust your teachers more than you guys are too trusting. Because we want v squared over r here. That's what we want here. If we want a slope that's going to be the mass, we know net force equals ma. So tension equals m v squared over r. If I want a slope that's going to be the mass, I want to plot this on the y-axis and this on the x-axis. So using the data we have to find a way of getting this. Well, v is 2 pi r over the period. V squared is 4 pi squared r squared over the period squared. And v squared over r is 4 pi squared r over the period squared. This is what we need to have in one of the columns. And this needs to be on the x-axis. And this is just the tension, and that's going to go on the y-axis. This should produce a graph whose slope will be a straight line. Yes. Yep. That's what you should get. Well, the first thing I did is I took both sides of this and squared it. That's what got me the v squared. I took this whole equation and squared both sides. That gave me the 4 pi squared r squared over t squared. And then divided both sides by r. So that canceled out one of the r's. All right. Well, bumbled through that.